All right. In the 1-1 warm-up, first thing we're going to kind of quickly talk about is the distributive property. This is something you guys should know coming in, but it's always something good to review. What the where the distributive property comes in from is order of operations, right? If I gave you the problem 3 times 2 plus 4, order of operations tells us we have to do what's in parentheses first, right? 2 plus 4 is 6, and that would give me 18. But what happens if I give you a problem like this, where the terms inside the parentheses cannot be combined? What do we do in this case? Well, what mathematicians saw is if I take and distribute the 3 to both of these terms, 3 times 2 is 6, plus 3 times 4 is 12, 12 and 6 add up to 18, you get the same answer. So what the distributive property is basically saying is every term inside the quantity gets multiplied by the number being distributed. 4 times 3x would be 12x. 4 times negative 1 is minus 4. Okay, so the written rule in a book would always be a times b plus c equals a times b plus a times c. And the number one thing you have to remember here is if you multiply and get a positive, you add. If you multiply and get a negative, you subtract. So, looking at this, if I wanted to simplify this by distributing, 4 times x is 4x. 4 times 8 is plus 32. Next one. 8 times negative 3x would be negative 24x. 8 times negative 2 would be minus 16. And this is simplified. Negative 3 times 2x is negative 6x. Negative 3 times 4, that's going to give you negative 12. Therefore, we subtract it. Remember, if you multiply and get a positive, you add it. Multiply and get a negative, you subtract it. Next one. Negative 7x times 3x is going to give you negative 7 times 3 is negative 21. X times x, x squared. Then negative 7 times negative 5 is plus 35, x. All right. Next one. Negative 6 times negative 3 is positive 18. X times x, x squared. Then negative 6x times 9 is minus 54x. When we involve fractions, remember when I do 2/3 times 6, I'm going to put 6 over 1, and I'm going to multiply the numerators. 2 times 6 is 12, over 3 times 1 is 3, and that simplifies to 4. So 2/3 times 2/3 x times 6x is going to give you 4x squared. Now, 2/3 times 9, that's going to give you 18 over 3. And a positive times a negative is a negative. That's going to give you 6x. And that's what we get. Okay? Now, rate of change. Remember, rate of change is no different. Rate of change is basically the slope of a line. So when I look at this, right away, this is an explicit rule for a linear function, right? And remember, the rate of change, this is m, this is x1, this is y1. So what is my rate of change or slope? 9. If I want to find the rate of change between 2 points, remember the formula is y minus y over x minus x. It doesn't matter which way you start as long as you subtract in the same order. So 6 minus 2 over negative 8 minus 12 will give me 4 over negative 20. A positive divided by a negative is a negative. 4 over 20 reduces to 1/5. Remember, 4 divided by 4, 20 divided by 4. The next example, right? If I look here, They give you f of a number equals a number, and then this represents the previous term. And if we're adding something to the previous term each time, what that basically tells us is this is the recursive rule for a linear function. And remember, the rate of change in a recursive rule is what you're adding or subtracting to the previous term. So in this case, the rate of change is positive 5 since you're adding it. When you're given a line in a graph, right, your goal is to find two nice points. So there's one nice point, and I can go there. Looks like I can go here, right? Remember, nice points are where two grid lines intersect, right? And if I look, I go up 1, so my rate of change or slope is positive 1 over 1, 2, 3, 4. So the rate of change or slope of that line is 1/4. Both of these are very important concepts for all of math. So we're warming up because we'll probably use it at some point coming up. Okay.